Video, we're going to go over trigonometric models after discussing trigonometric functions and inverse trigonometric functions. So starting with some notes here, what is a periodic, or what is periodic behavior in general? It's behavior that repeats at, so it's repeating, right? That's important, at regular intervals of time or time intervals or intervals, just in general, right? Regular intervals. Examples of this, we talked about pendulum. A pendulum is an example. A metronome is an example. Just mention tidal waves. There are other examples, of course, and you can see those, and you can read about them in the textbook. I believe it starts on page 445. So with this, we're gonna get to the idea of simple harmonic motion. It says if the equation describing the displacement y of an object at a time t, or at time t, is y equals a sine of omega, this is omega t, or y equals a cosine of omega t, then the object is in simple harmonic motion. That's how simple harmonic motion is defined. Harmonic motion. Now let's go back to, we know what A is in absolute value. A is the amplitude. And that describes basically the maximum displacement from equilibrium. Displacement from equilibrium. Sometimes we say from rest. At 2 pi over omega, again, this is a Greek letter, it's omega. And 2 pi over omega is the period, which is basically the time to complete one cycle, time to complete one cycle. Time it takes to complete one cycle. That's what a period is. If you take 1 over that, or just the reciprocal, that would be the frequency. Sometimes you'll see it in the books as F, or this letter nu. It's more like this. Okay, which describes basically how many cycles per unit of time. And make sure you know what the unit of time is. And that is normally seconds or minutes or hours or years. So just be careful what the unit of time is. Now, note the amplitude is a in absolute value, right? Which is always positive because it's a distance, where just a may or may not be. So meaning this a may or may not be negative or positive. Example 1, write the equation describing the motion of a ball that is attached to a spring suspended from the ceiling with period 3 and 3 seconds, and maximum displacement from equilibrium is 7 inches. So that's basically the absolute value of A. Assume you pull down and let go at time t equal to 0. Okay, so those are important um, pieces of information. The period is t. In the book, you'll see t as this. It's like a tilted bar and then t, which in this case is 3 seconds. We also know that omega is 2 pi over t. Again, this is the period here, that was t, right? So omega is 2 pi over t, which is 2 pi over 3. Now keep in mind, omega is the frequency, right? That how many cycles. In this case, it's going to be how many radians we have per second. Sometimes this is referred to as the angular speed, commonly. Angular speed. Okay, so we have the period, we have omega, and we want to build the equation, which is y equals a cosine of omega t. And you also pull down, right? Remember the motion from kind of like a max to min, or to mid-min. So a cosine of omega t, this becomes, a is positive here, which is 7, and then cosine of 2 pi over 3. t in close parentheses. All right. Now here, again, note, I'm going to say here, downward motion is defined as positive, right? So if upward is positive, if upward was positive, then you'd get what? Then you'd get y equals -7 cosine of 2 pi over 3t. Okay? So here, in a way, you would be starting at 7 inches below, right? And you're going up below equilibrium, start below equilibrium. Equilibrium. Okay? So that's the difference. Now let's move on. Let's move on to the next example, example 2, which says, given the equation for simple harmonic motion, d equals a cosine of 4t, find the maximum displacement. So that's absolute value of a, which is 8. Find the period. That's the period, which is 2 pi over omega, which is 2 pi over 4, which is, remember, this is omega t, the 4t. And then that's pi over 2. So this is done. A is found. And the frequency nu, or f, is omega over 2 pi, which in this case is the reciprocal of what we just got, or 1 over t, which is just 2 over pi, or 4 over 2 pi, which is, sorry, 2 over pi. Okay, so we are pretty much done here. We don't know the units because really we were not given the unit for time. We don't know how much time is expressed in whatever unit it is. Number 3, naturalists find that the populations of some kinds of predatory animals vary periodically with time. Assume that the population of foxes in a certain forest varies sinusoidally with time. Records started being kept at t equals 0 year. A minimum number of 200 foxes appeared at t equals 2.9 year. The next max of 800 foxes occurred at t equals 5.1 year. Find the equation that matches the situation. So we have a good chunk of information here. So let's start with amplitude, and this is the norm. You start with amplitude, which is the absolute value of A. So amplitude is going to be max minus min, and all that is divided by 2, which in this case is 800 minus 200 divided by 2, which is 300. So this is the amplitude. 2, the second piece of information, we went from a minimum into the next max, right? So this is from the minimum to the next max. That means we went half a period, which is also to say that what? That the period twice is equal to 2 times max minus min. Okay, so the difference between max and min, that's half a period. So the period is twice that. Okay, and now we have the numbers. So therefore the period is equal to 2 times our max was at 5.1, min at 2.9. You subtract those, you get 2.2 and multiply by 2, you'll get basically 4.4 years. That's the length of one period. And then omega is basically 2 pi over the period, which is 2 pi over 4.4, which if we simplify, we get approximately 1.428. Now just be careful that we try to simplify one time toward the end when possible. Okay, so if I want omega to 3 decimals, I just got it to thousandths. Now let's put the equation together. How do I know if A is positive or negative? I started at a min and then I went to the next max, right? So my motion is going to be up, for cosine is negative, and it's going to be negative from negative 300 cos of what? 1.428, and remember there's a phase shift of 2.9. So it's 1.428 quantity T minus 2.9, close parenthesis, close the other parenthesis, and then don't forget here, if we're going from, if 300 is my amplitude and 200 is min and 800 is max, that means my midline is at 500, right? You can also do 800 plus 200 divided by 2. So that's plus 500, and that is my final equation. So make sure you know how to find these elements first and put them together to write the equation correctly, because just like this example, the follow-up parts or pieces are gonna rely on your correct equation. So part B says foxes are declared an endangered species when their population drops below 300. Between what two non-negative values of t where the fox is first endangered using graphing technology. So we want to take our equation, which is negative 300 cosine of 1.428 or 28 quantity t minus 2.9 close parenthesis plus 500. I want to set that to be less than 300. So we start working on this algebraically, and at the end we can use a graphing utility. In this case, I frequently use the TI-84 plus, and I recommend that. So here you will end up by subtracting 500, negative 300 cos of 1.428 t minus 2.9. This is a minus and this is a dot. 2.9 is equal to or is less than negative 200 by subtracting 500 from both sides. And then by dividing by negative 300, you're going to get cosine of 1.428 parenthesis t minus 2.9 is greater than 2/3. So one way to do this, right, is to graph. You want to graph this piece, and you can replace t by x, right, on the graphing calculator. So you're going to graph this, and you're going to also graph the line y equals 2/3. So you can call this y1 equals, and this is y2 equals, right? And you can graph those, and when you graph them, you want to see where your cosine, right, is above the line 2/3. Okay, and you want to trace, so you want to do second trace. And remember, you want to be here, there was a keywords, there were keywords, two non-negative values. So as you do that, as you graph, and we can discuss this in class if you need support, you're going to see that t is going to be, so you will find two values here that are non-negative. They were first endangered, right? T is going to be an element of approximately 2.31 and 3.49 years. So this is the time frame in years in which the population of foxes was first endangered. Okay, and those are two non-negative values, so meaning you don't want to go back. Okay. All right, and they could be endangered here again, right? If I continue this model, but this is where they were first endangered. All right. So for that was example 3. For example 4, it's an interesting example, also very common. Ferris wheel example. It says in the Ferris wheel pictured at the right, Darlene is in the seat labeled point D. So she's right here. The right start at time equal to 0. So that's when she's timed, and it takes 10 seconds for Darlene, 10 seconds for Darlene to reach the top of the wheel. So this 10 seconds, right, is your shift, is your C in the equation, where she will be at 45 feet above the ground. The wheel turns at a uniform speed of 2 revolutions per minute. That means this is 1 revolution per 30 seconds, right? And technically that is your period. Okay, that means every 30 seconds you do a full loop, which is the period. So what is the radius of the wheel? Now, just be careful here. Notice the 45 is from the top of the Ferris wheel, really to the ground, right? So, and then there still is, and this is 25 feet from the center of the wheel to the ground, which means, um, if this entirely is 45 and then 25, then the difference between them, if I subtract them, I'll get this piece, which is the radius. So the radius r is 45 minus 25, which is 20 feet. And if the radius is 20 feet, this leaves me with this piece being 5 feet, because this is 20 and then 5, so for a total of 25. How is this number related to the sinusoidal function we will use to represent this problem? So the radius is equal to 20, which is technically a, right? Or 20 feet. That's really a. How long will it take to complete one cycle? We just said 60 seconds or 1 minute per 2 revolutions. So 60 seconds per 2 revolutions, which is 30 seconds. That's the period. How is this number related? Just mentioned that this is period equal to 30 seconds. So those are key, right? And pieces of information. What is Darlene's minimum height above the ground? So the minimum height, I just labeled this in green. That is 5 feet. What is the maximum height above the ground? We mentioned that earlier. That was given to us, in fact, 45 feet. Write a sinusoidal function to model, right? So I'm going to say height h of t equals, initially you start with a cosine, right? And remember, it's a cosine b quantity t minus c close, and then plus d, right? So let's put things here together. Remember, b, we have to put these elements together. B is 2 pi over, the period is 2 pi over 30, which is really pi over 15. And d is max plus min. Remember, that's the midline, max plus min divided by 2, which is 45 plus 5 divided by 2, and that's going to be 25. So I have B, I have D. I already got the phase shifts from earlier, which is the 10 seconds, and C is 10. And I know my amplitude from part A, which is 20. So I need to put all this information together. So H of T is equal to 20 cos of what? Pi over 15, open parenthesis, pi over 15, then open another parenthesis, T minus 10, that's your C, close parenthesis, and then close parenthesis again, and then plus what? Plus 25. All right, that's your equation. Now that we have the equation, we can answer part E, which is what was Darlene's height above the ground at the beginning of the ride? That means that time equal to 0. So let's put this together. This is time equal to 0. If you plug in 0 for time, you get h of 0 equals 20 cos of pi over 15 times what? Times what's going to be negative 10 pi over. So let me clean this up. This times negative 10. So it's negative 10 pi over 15 and then plus 25. So this will be 20 cos of divided by 5 negative 2 pi over 3 and plus 25. So this is equal to 20. Cosine of negative 2 pi over 3 is negative 1/2. So it's negative 1/2 plus 25, which is negative 10 plus 25, which is just 15 feet. And that's really Darlene's height above the ground at the beginning of the ride. So here, when she was here, she was at 15. Now the picture is not very, indicator of that, right? Especially that this is 5. But the numbers speak louder than, right, the picture. Um, the picture there is not really accurate or to scale. And then in the first minute, when was she closest to the ground? So closest to the ground, if you're thinking of cosine and sine period, when you're closest to it, you're like the lowest, right? Which means you're at -1. So I'm gonna set what I'm gonna say here, which is basically at 5, right? At 5 feet. So closest to the ground, you're gonna say cosine of you want this piece, cosine of pi over 15 of t minus 10. You want this to be equal to -1, basically, right? Which is actually cosine of, if you think of, oh, sorry, I said sine, cosine. I was thinking of sine. Cosine is -1 right here. Cosine is the x value right here. So you're at pi, right? This is cosine of pi. So therefore, pi over 15 times t minus 10 should be equal to pi. And this gives you t minus 10 to be equal to 15, which means t is equal to 25 seconds. I believe it's in seconds. Yeah, seconds. Okay, so let's clean this up. Make sure you include the units. And this concludes example 4. Okay, now let's do some more practicing here. It says the word, this is the same question. I would encourage you to try it because it's again a Ferris wheel. So I'd encourage you to try it on your own and then we can share the answers in class. Let's just skip and do number 2, right? Because it's slightly different. Number 1, it works exactly the same setup as example 4. Number 2 says the time between high and low tide in a river harbor is approximately 7 hours, the time. Okay, then it says the high tide's depth is 16 feet, occurs at noon, and then the average harbor depth is 11 feet. Write an equation modeling this relationship. So let's try to understand what these words mean. When we say high, right, we said high tide. High and here it says the time between high and low is 7. So you're saying from high to low, right? is is 7, and that's half a period again. So half a period is 7. That means the period is 14 hours. Okay, that's simple to understand, right? It's not challenging. Just remember from high to low, that's half a period. Now, then it says the high tide depth of 16 feet occurs at noon. So you have 16 is high, and then the average depth is 11. So 11 is average. Okay, which is technically another way of saying the midline, right? So from here, I get that from the midline to the high, is the amplitude is what? Is 16 minus 11, which is just 5. Now, run an equation. So we are starting, it says the high tide of 16 occurs at noon, and then the average. So you're starting at a max, right? Start at max of 16 feet. So let's see. So that start at max, that means here you're going to start at cosine with a positive amplitude. So cosine of, so let's put a d of t actually. D of t is equal to 5, that's the amplitude, cos of what? Now think about 2 pi over b, right? 2 pi over b. How much is 2 pi over b? That's 2 pi, we already said b is 14, so 2 pi over 14, which is pi over 7. So this is going to be pi over 7 t, and then close that, and then plus the midline, which we just said was 11 right here, the average. Okay, so 5 cos quantity pi over 7 t plus 11, that's the equation. Part B, if a boat requires a harbor depth of at least, that means at least, right? Greater or equal to. Find the next two. So if a boat requires a harbor depth of at least, so D is the depth you want. So I would like you to kind of set this up. So you want D of t, and try this on your own again, to be at least 9 feet, right? Which means you want to take your equation t plus 11 to be at least, that means greater or equal to 9. And then you're going to solve for that. Okay, so you'll get cosine of pi over 7t. If you subtract 11 from 9, which is -2, and divide by 5, you get -2 over 5. Okay, and then you can solve for this. From there, these are all TI-84 graphing calculator. So you're going to use y1 to be this, y2 to be that, and then see where cosine is greater than or equal to this value by tracing. Okay, so take a moment and think about this. Now I could change this to at most, right? It requires harbor depth at least. Yeah. So just be careful with the language. So that was number 2. I'll do one more and you can finish number 2. Number 3, bouncing spring problem. A weight attached to the end of a long spring, this is also a common problem, is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. You start a stopwatch. When the stopwatch reaches 0.3 seconds, the weight first reaches high point. So at this point, you're reaching a high point of 60 centimeter above the floor. And then the next low point, 40 centimeter above the floor, occurs at 1.8 seconds. So we're kind of repeating, right? We're kind of repeating the same thing over and over again. So let's try this. Let's start first with, we have high here, high, which is 60 centimeters, right? And this is at t equals 2.3 sec. Then we have low, which is 40 centimeters. And that's at t equals to 1.8. Okay, so that means if we go between here and here, that means the midline is at 60, oops, is at 60 plus 40 over 2, which is at 50. That's the midline. Now, how do I find the amplitude? Amplitude, we said max minus min, so high minus low here divided by 2, which is 60 minus 40 divided by 2, which is 10 centimeters. That's your amplitude. Now, we also going from high to, it says the next low. So that's also half a cycle, half period, which is from 0.3 to 1.8, and that's really 1.5. So that's half a cycle. That means period is twice that, which is 3 seconds. 3 seconds. Okay, then it says a high occurrence. So when we say high occurrence at 0.3, that's where we start, right? That means you start cosine and then it's shifted to the right. So you start at positive a. Your equation is going to be y equals a, which is a, or positive value for absolute value of a here. It's a actually, right? So it's positive 10. And then cosine of 2 pi over b, which is what? Which is 2 pi over 3. And then in parentheses, t, and what's the shift? We started at 0.3 seconds, 0.3 close parenthesis, close outside parenthesis, and then plus the midline, which is at 50. The most critical piece is this, to set the equation up, because the rest is going to follow from it. What's the distance from the floor when the stopwatch reads 17.2 seconds? So you're going to just find f of, we can call it f of or y of. Let's call it f of x here, or f of t, right? So you can see f of 17.2. And that's going to be 10 cosine of 2 pi over 3 times 17.2 minus 0.3, close that, and then plus 50 on the outside. So this is the point, is that you can find all these values using a calculator. Okay, again, the most important piece is the setup. This is 16.9, and then plus 50. You can find the number. Okay, this will be approximately 40.7 centimeters, I believe. Okay, so double check. You can do the calculations on a scientific calculator or on a graphing calculator. Now, what is the positive value of time when weight is 59 centimeters above. So you want this whole equation to be 59. So 10 cos of 2 pi over 3 quantity t minus 0.3 close parenthesis plus 50 is equal to 59. By subtracting 50 from 59, you'll get 10 cos 2 pi over 3 t minus 0.3 close equals to 9. And then you get cosine of 2 pi over 3 quantity this is equal to 9/10 or 0.9. Okay, which means you're gonna find, if you want to find the angle here, you're gonna do inverse cos, right? That means 2 pi over 3 quantity t minus 0.3 is equal to inverse cos of 0.9. And then t minus 0.3 is gonna be 3 over 2 pi inverse cos of 0.9. And then t is gonna be 3 over 2 pi times inverse cos of 0.9 and then plus 0.3. Okay, and you can check what that answer is. You can also plug that in the calculator. Okay, the rest of this stuff is really pretty quick, just quick reviews. Those are not super difficult. Is inverse sine of 1/2, that is pi over 6. Inverse cosine of 1/2, that's pi over 3. Inverse tan of root 3 over 3, that's pi over 6. Arc cosine or inverse cos of root 3 over 2, that's pi over 6, and so on and so forth. Okay, so just these are common values, arcsine, right? Pi over 4 of root 2 over 2. Arctangent, also pi over 4. Right? Those are just very quick. This is not a big deal. Then you can also practice these values here. Cos of inverse cos, we did this for the quiz. And we're gonna continue to practice it, right, for the test. This is really inverse cos, and I would recommend you try to do a draw a triangle and so on. Extra graph practice. We can do a couple of them in class as a warm up, and there's more here of graphing. Okay, so these are just extra practice problem. You can use them, and at the end, these are just the identities, right? The Pythagorean identities, which is just cosine squared plus sine squared equal to 1, etc., etc. Cosine squared is 1 minus sine squared. Sine squared is 1 minus cos squared. 1 plus tan squared, that's secant squared, etc. You can fill those out. Cotangent squared, that's cosecant squared of x. And tan squared is secant squared minus 1. So those are just quick fillers, really. They're not very substantial. Okay, secant, remember secant is 1 over cos. Cosecant is 1 over sine of x. Don't forget the angle, right? So don't just say 1 over sine. It's sine of x or sine of theta, right? Even in identities. Cotangent is 1 over tangent. Cotangent of x is 1 over tangent of x. Cosine here is even, so it's cosine of x, cosine of negative x. Sine is odd, so it's negative sine. And tangent is the ratio of that, so it's negative tangent. So it makes making tangent also odd. Cosine of x plus pi over 2, I would like you to visual those, right? Like if x is here and you're adding to it pi over 2, right? The cosine becomes what? It becomes, so think about cosine of this, right? It's the opposite of sine, so it's negative sine. It's negative sine of x. Sine of x plus pi over 2, right? So again, you can draw a triangle. You can see x is here, right? This is x. And this is x plus pi over 2, or pi over 2 plus x, right? The sine of this is the same as the cosine of that. So sine here is going to be just cosine. I'm sorry. And the tangent is the ratio. So it's going to be a ratio, but it's going to be the ratio of sine over cosine, which now is cosine over negative sine. So it's going to be negative cotangent of x. Okay, and cosine here, cosine of x plus or minus pi, that means if you have an angle and you add pi to it, right, what's the cosine? Right, if you add pi or take away pi, if you add pi, you're going to have opposite values of cosine. That's going to be negative cosine of x. If this is your angle and you add pi, the sine is also the opposite. Sine used to be this, now it's that. They're opposite, so this is negative sine. And the tangent is the ratio, which is going to still give you a tangent, and so on. Adding or taking away 2 pi, that's going back to the same point, both for sine and cosine, and tangent as well. So these are pretty quick. You don't need really the double angle identities. I'll just share them, but you don't need them. You may need them later. You're probably going to need them when we do more advanced trig. It's a good idea to kind of get familiarized with them. And these could also, and will be proven. This is cosine squared x minus sine squared x. This is one identity. Or you can rewrite it as 2 cosine squared x minus 1, or 1 minus 2 sine squared x. These are identities we'll talk about later, and this is 2 sine x cosine x. They can all be proven, and we will prove them. And tangent of 2x is 2 tan x over 1 minus tan squared x. Again, these are not part of your test, the double angle identity. So, and I would say the rest of them, right? You don't need them. You would need them here. It's good to have them here for the advanced trig unit, which is coming up later. Okay. But technically, just keep study up to this point, right? Up to this part of this one, page 38, for your upcoming exam. I strongly recommend you get yourself familiarized with these sinusoidal um, um, word problems using the problems that are solved here. Make sure you kind of break down the setup, find A, B, C, and D, and put them in the equation correctly, and then apply to find, the follow-up questions. Thank you for watching. I hope this was helpful. If you could watch it today, that would be great. And I will see you in class next time.